All right, this is the first of a two-part video. We're going to start by solving a two-variable system. So there's an x and y, and then the next video is going to be a three-variable system, so it's going to be x, y, z. The three variable is essentially just the two variable on steroids, in that you have to do this process a couple times to even get started to solve a three-variable system. The thing is that you can only solve one variable at a time. So we're going to eliminate a pair of variables in order to just be left with one. And then we work backwards to solve the system. So just in a nutshell here, and you can look this up for more information, but this is going to eventually be in the simplest form, three lines, right? And we're trying to see if these three lines intersect. We want to see if these three lines are parallel, in that, none of them touch, so they have no solution. And then the last one is going to be in which, all lines that you draw overlap each other, and this means that they have an infinite amount of solutions. But again, we'll talk more about this in the next class, simply as review, because we've already talked about it last week. So let's get started here. So there isn't a straightforward approach. There isn't like a textbook step-by-step way to solve this for every single variable. The goal here is to look at which variables do you want to get rid of first, x or y. In this particular case, we only need to get rid of one, leaving us only with the other. So because I see x by itself, I want to focus in on x and get rid of just the x's. So to make things simple and uniform, I'm just going to label this as equation 1 and this one as equation 2. So in order to get rid of the x's, equation 1 has to have negative 2x, because if I add negative 2x to 2x, the x's will cancel out. So just follow along here. I'm going to go ahead and draw a line so I don't have to touch my originals. I'm going to take equation 1 and then multiply it by negative 2. And so I'm going to multiply the entire equation by that, negative 2. So this results in the following. So this is going to be my new equation 1. So I'm going to have negative 2x minus 6y equals negative 12. So now what I'm going to do is I need to add this to equation 2, right? I need to add them together. So as a result, I'm going to bring down equation 2. Okay. And then I'm going to add equation 2 and equation 1 together. I'm just going to add them. Okay. This is going to allow me to eliminate the variable x. But just keep in mind that sometimes things can happen in which more things than you originally planned to get eliminated. And that's okay. You just roll with the punches. So I'm going to draw this little squiggly line. And I'm going to add 1 and 2. So negative 2x plus 2x is 0. Okay. Negative 6y plus 8y, this is going to be 2y, equals, and then in this particular case, we have negative 24, right? I was about to say 0, but negative plus negative is more negative, so negative 24. So now, in order to solve for y, we need to do the basic math, right? We need to go ahead and divide both sides by 2, and this leaves us with y equals negative 12. Okay. So now we've solved for one variable, but we need two, right? Because why? Because this is a two variable system. We need to get x equals something. So when you're left with this last step in a two variable equation, all you have to do now is plug it back in. Okay. Plug it back in where? Into the original is the best thing to do. So I'm going to plug in this negative y to the easiest y I see out of these two, so that I can solve for x, right? To be honest, I'm just going to plug in negative 12 into this y here. So I'm going to use equation 1 because x is by itself already, right? So I'm thinking in my head that that's going to make my life easier. So I'm going to go ahead and write equation 1 plus 3 times, not y anymore, but what y equals, and that's negative 12 equals 6. Now, I'm almost done. I'm going to go ahead and just solve for x. So x minus, because this is going to be a minus, 3 times negative 12, that's 36 equals 6. And doing a little bit more math, that leaves me with 6 equals 42, I believe. So hopefully I did my math correctly, and this should equal the solution to the system. So you can leave it like this if this were on the exam, which by the way it's not. A three variable system will be. You could write it as a coordinate, so it would be 42 comma negative 12, and then that's it. For a 2 system, it's just as straightforward as this. This is going to be your solution, and then you're done.